Okay, today we are going to do the derivative of trigonometrical functions. If you find the gradient of sine x, you'll get a cosine x function. If you find the gradient of cosine x, you will get a negative sine x function. If you differentiate tangent x, you will get a secant square x function, and it will look like this. Right? So if you get the gradients of tangent x, the gradients will all look like this, and this is actually a secant square x function. So what happens if the x is ax plus b? You have to differentiate the bracket. So I will differentiate the bracket and I'll bring out the a. I'll differentiate the bracket, I'll bring out the a. I'll differentiate the bracket, I'll bring out the a. The rest no change. And finally, what happens if you have a power? Bring down the power minus 1, differentiate the trigo function. Bring down the power minus 1, differentiate the trigo function. Bring down power minus 1, differentiate the trigo function. Okay, let's use this example as a consolidation of all these three ideas. So we use something called PTI. P stands for power. You must bring down the power, and the power you must minus 1. Let's do step by step. Okay, I'm going to do it in red first. First, I will rewrite this question. Okay, for beginners, let's rewrite this as tangent 2x minus 1 cube. So that it's easy to see the power and the trigo function. It's easier to see the difference between the power and the trigo function. So let's do it in red first, which is bring down the power and the power minus 1. So copy the whole thing first. Power minus 1. Okay, let's write this way. Next, I'm going to do the blue color part. I'm going to differentiate the trigo, but do not change the bracket. Do not change anything inside the bracket. So let's differentiate the trigo, which is this part here. Okay, just differentiate the trigo part. So I will have secant square. Do not change the bracket. Okay, I just differentiate the trigo part. So tangent becomes secant square. And finally, I will differentiate the bracket. Which bracket? Actually, it's this one. Okay, so it's in sequence. The power first, the trigo part, and then now I've got to do the bracket. So I will differentiate 2x minus 1. Okay, simplifying it, the answer will be, always look out for the constants. Then you can write this or this first. So I usually will write this part first, but it doesn't matter. And I now write back this as tangent square 2x minus 1. Okay, you must be asking, why must I write this form? No, you don't need to write this form. Okay, I explain why this form is easier for the beginning part. Okay, now, if I start the question exactly like this, so let's follow. Bring down the power minus 1. Then I do the tangent part, right? The tangent part looks a bit complicated. But if you look at the tangent part here, it's just like that, without the powers inside. You see? You see, I do the P already, right? Now I'm going to do the trigo part, not the tangent. Yeah, the trigo tangent part. I'm going to do the T now. I'm going to do a T now. So in your mind, you have to make the power like disappear like that. So if I differentiate the trigo, it will be secant square 2x minus 1. Looks very complicated, right? When you want to differentiate the trigo, because this part looks complicated. But if you write it in this form, when I want to do the PTI, the T part, I only need to just focus on this. This is the T part. So when I differentiate this, quite straightforward, you will get secant square 2x minus 1. And for the I, okay, I've done the PT, and then I've got to do the I, which is the bracket, which is here. So roughly it's the same, just that the T part is a bit clearer if you write it in this form. So I don't know about you. I let you decide lah, whether you need to write it in this form, okay, or you just want to straight away do the P, T, and the I. Okay, yeah, Jacob.